In this video tutorial, we're going to demonstrate how to configure Dream Report to connect to a PCVue SCADA system, access PCVue real-time values and alarms, and historical values and alarm logs using the various PCVue communication drivers included in Dream Report, and how to create and generate reports with data from PCVue using Dream Report. So let's talk about Dream Report's communication drivers for PCVue SCADA software. In this slide, we'll list all PCVue communication drivers included in Dream Report. We can categorize these into PCVue communication driver types, those for accessing real-time values and alarms, and those for accessing historical data and alarm logs from PCVue. When we expand the ARC Informatique folder in the Dream Report Communication Driver Wizard, we see the list of available PCVue drivers. For communication with real-time values and alarms, we have three options. If Dream Report is installed on the same machine as the PCVue HMI, using the OPC real-time values driver is a quick and easy way to access real-time values. If PCVue is on a local or remote machine, and if PCVue Web Services is configured, we can access the real-time values using the Dream Report Web Services real-time values driver. And for real-time alarms on a local or remote PCVue node, we can use the Web Services real-time alarms driver. For communication with historical data and alarms logged by PCVue, we also have three options. Using the Historical Data Server, or HDS Database Historical Values driver, we can connect to the local or remote SQL Server database where PCVue is configured to log its data values. Using the HDS Database Historical Alarms driver, we can connect to the SQL Server database where PCVue is configured to log its historical alarms. And finally, if PCVue Web Services is configured, we can access the historical data logs using the Dream Report Web Services Historical Values driver. In this final slide, we'll follow a typical workflow in creating a Dream Report project using data from a PCVue SCADA application. First, we'll open the Dream Report Design Studio and create a new project. Then we'll open the ARC Informatique Communication Drivers folder and then decide what type of data we want to report on. Real-time data or alarms, and/or historical data and alarms, and then configure the appropriate driver or drivers. In this demo, we'll configure all of the PCVue drivers. If configuring any of the real-time values or alarm drivers, then we need to create logging groups in Dream Report to store the data into the database of our choosing. At this point, we are ready to create a new report. We can drop any kind of tabular, chart, or calculation object on the report, and browse the various data sources for any tags to use on the objects. After configuring the object, we can start Dream Report's runtime engine and generate the reports. I'm going to launch Dream Report Studio and create a new reporting project. I'll accept all defaults. After the blank project is created and Studio opens, the Communication Configuration Wizard opens automatically, and I'll expand the list of PCVue communication drivers under the ARC Informatique folder. We'll start off by configuring the three real-time drivers. In this first example, we want to access real-time values from the PCVue HMI, so we'll configure an instance of the PCVue real-time values using OPC driver. We first add a logical name, and then configure the driver. For this driver, simply select the PCVue OPC data server from the list of installed OPC servers on the Dream Report PC and test the connection. If the PCVue HMI is on a remote machine, we recommend using the PCVue Real-Time Values Web Services driver covered next. Click OK to close the configuration window, and then make sure to click Add to add this instance of the driver to the defined drivers list. In this next example, we want to access real-time values from the PCVue HMI, but this time using an instance of the PCVue Real-Time Values Using Web Services driver. We first add a logical name and then configure the driver. If Dream Report is on the same machine as PCVue, use localhost for the host address. If remote, use the IP address. If accessing the remote PCVue node requires the use of a proxy server, enter the proxy address and proxy port here. Since secured web services are used, we need to provide a valid username and password that were configured on the PCVue Web Services side. In this case, I'll use the default web user account from the PCVue HMI sample project. The Use Alternative Language option defines whether primary or secondary language will be used for tag description and other text data properties. Click the Test Connection button, click OK if successful, and then click the Add button to add this instance of the driver to the defined drivers list. Next, for the PCVue real-time alarms using web services driver, we add a logical name and then configure the driver as we had done in the previous web services example. We also have the option of including PCVue alarm specific features like the label and variable title associated with the alarms. Again, enter the web user credentials, test the connection, and then click Add to add this instance of the driver to the defined drivers list. Now let's configure the various PCVue historical values and alarm drivers. The HDS items driver allows DreamReport to connect to a SQL Server database containing the PCVue historical data logs. I'll add a logical name and then configure the driver again. The server name is the name of the server running SQL Server. It can be remote or on the local PC as I have here. For SQL Server authentication, you can either use Windows Authentication, assuming that your Windows account has rights to the SQL Server and the PCVue database, or a SQL-specific account. Test the connection and if successful, select the database name that was configured for the PCVue data logging. Click OK, and then click Add to add this instance of the driver to the defined drivers list. To get access to historical alarm logs, we need to use the PCVue HDS alarms driver. I'll add a logical name and then configure. The server name is the name of the server running SQL Server, which is my local PC. Again, enter valid credentials for SQL Server, test the SQL connection, and then select the database name used for alarm logging. You have the option of configuring the driver instance to retrieve alarm logs or event logs. If you need access to both alarms and events, you would create two instances of this driver, each with the appropriate alarms or events option selected. You can tweak the driver to return the description of the event title or the alarm text as well. The next part of the HDS alarms driver configuration is to set the alarm filters, which can be used later on when configuring the alarm table object to only return certain alarms. For instance, specific alarm priorities, alarm types, etc. The first filter I'll create will be my default filter to show all alarms. After naming the filter, I'll select the table in the database containing the alarm logs. I'll set the filter condition property to be alarm level and the condition to be less than 1000, which will be all alarms. I need to click the Add Condition button to add this condition to the filter, and then click Add Filter to add this new filter to the list. Let me add another alarm filter, but this time to filter out only high-priority electrical alarms. So, first I'll create and add a new filter name, and give it the name High Priority Electrical Alarms. Then I'll add two conditions, the first being alarm level less than 10. Then I'll use the AND condition, and then the alarm description, like %electric%. Note that the % sign is the SQL wildcard character. Click on the alarm filter name to save the changes, and then finally click OK and Add to add this instance of the driver to the defined drivers list. The last driver we'll configure is the historical values using web services driver. This driver is configured exactly in the same way as the web services real-time values driver. Again, note that the credentials you enter must be a valid login configured on the PCVue web services side. This is not a Windows or a SQL Server account. Test the connection, and if successful, click OK, and then click Add to add this instance of the driver to the defined drivers list. We're now done setting up the PCVue communication drivers for this project. Since DreamReport has a built-in data logger, from which you can log any real-time data and alarms to the database format of your choice, we'll configure a couple of logging groups to log data from the real-time PCVue data. Of course, if your data is already being logged using PCVue's historical logging functions, there's no need to create logging groups in DreamReport. Before I set up my logging groups, I want to show you where to specify what database will be used for data logging. I'll go to the Project tab and then select Database Definition. You'll notice that MS Access is the default database format. I am going to use an Access database in my demo, but in a production system, we highly recommend a more robust database platform like SQL Server or SQL Express, MySQL or Oracle. An Access or SQL Server database can be natively selected, or you can use an ODBC connection to connect to any other database. Dream Report will then take care of building the complete database structure for you. Okay, let's close the database configuration, go to the Logger Studio section, and right-click to create a new logging group. I'll name this group Group Delta, as we'll set the logging mechanism for all tags in this group to be stored on change, or Delta stored. The source of tags for this group will be the PCVue OPC real-time values we configured a few minutes ago. You'll notice that the browsable tag structure is exposed through the OPC driver. I'll add a few discrete and text tags to this group, as I only want to record these tags when they change state. After I browse and add these tags to the list, I'll set the record rate for this group. We'll use the default onChange setting. You can also set up conditional logging and have additional flexibility on how you want the data to be recorded. To verify that Dream Report can access the live data, I'll start monitoring. Here we see current values for these tags. I'm going to add another logging group, this time to log a set of analog tags at a 5-second frequency. Let me name the group, and this time the tag data source for the group will be the Web Services real-time values driver. And we'll select a set of analog tags, levels, temperatures, simulation tags, etc. After selecting the desired tags, I'll set the record rate to be every 5 seconds for this group. There we see the live data coming through. I'm going to start running the project now, so that Dream Report will create the database for me and can start logging our data while I'm building the new report. So let's create a new report. We'll start with a default report, Report 0, and give it a name. Let's call it PCVue Report 1. Let's leave most of the defaults, but we'll change the report generation time to be daily, just after midnight. We could also trigger the report to be auto-generated based on an event. This is where we could use any real-time tag from the PCVue HMI or from a PLC, for instance, for the report trigger condition. I'll look for the Level 3 tag in PCVue to exceed 500 as the report trigger. Finally, I'll set the report format to be both PDF and web, and set the option to open the PDF after generation. This is where I could also set up automated emailing or printing of the report, or setting the output to be Excel or CSV file. Now that we've set up the basic report settings, let's start adding objects to the report. We'll start with the automatic statistic table to summarize data from a set of analog tags logged in PCVue. I'll select the object from the right side toolbar and place it on the report. We now need to browse for tags from an external history server. Since we configured both the HDS historical items and Web Services historical values drivers, we can use either. So I'll use both sources in this object. And I'm going to select the Web Services historical values data source we created earlier. You'll see that the PCVue tags folder structure or hierarchy is exposed. I'm going to select a few analog simulation tags here. While I'm here, I'll switch to the HDS values driver instance. You'll notice two tables from which to select tags. This is dependent on the table names that were defined when setting up data archiving in PCVue. I'll select the Trend Table 1 folder, and then select a few tags that are being logged there. Next, I'll set up the time period to report on. I'll select the last 1 hour. Finally, I'll select the various aggregates or statistical functions we want to include. Let's display the min, max, and average values for these tags, as well as the times when the min and max values occurred. Let me add captions for each tag instead of showing the full tag names on the table. We can further configure each of these functions, if necessary, for conditional formatting, decimal places, engineering units to display, captions, etc. I'm going to flag the humidity tag in red if its average value was less than 30%. Detailed configuration of the automatic statistic table is covered in a dedicated video tutorial. I'll now go to the Appearance tab to show the descriptions instead of the item names, and give this table a title. After closing the table configuration, I'll do some basic column formatting, and then we're done with this table. We're now going to place a line chart on the report. This time, I'll use data logged in the Dream Report database as opposed to the PCVue historical logs, so I'll get data from Dream Report history, the tags logged from the PCVue Web Services real-time driver, and add a couple of level tags to my trend. The first tag I'll add to the chart is the level tag, and give it a caption for the legend. I'll repeat this for the level 2 tag, and since these are both tag levels, I'll have them share the same y-axis scale. Now let me go over to the Appearance tab to name and format the line chart, add units to the scale, and display the legend. For the chart's plot type, I'll select a smooth line. I'll also enable the web-specific features. Chart Web Interactive will allow us to interact with the chart, like zoom in or zoom out on the chart on the web page, and the Raw Data option, which will allow us to click on the chart on the web report and view the raw data and save it off to a CSV file if needed. I'll now add a few single data objects to show the current or live values of some temperature tags, and another single data object to give me the max value of some tag for today. So I'll start off with the first object, select the current value function, and then select the tag from one of the real-time data sources. Note that for the current value function, the tag does not need to be logged. Dream Report will display the current value at the moment of report generation. I'll do some formatting, and we're done there. I'll duplicate this object now and replace the tag. Finally, I'll add one more single data object. Select the humidity tag from the PCVue history. And then select the average statistical function. I'll do some formatting and also enable the raw data hyperlink option, which will allow us to drill into the raw data behind this calculation on the web report. Okay, let's format and align these, and add a few text labels. The last object we'll add to the report is an alarm table, which will get alarms logged by PCVue. I'd like my alarm table to start on a new page, so I'll right-click and insert a new page on my report. I'll pick and place the alarm table on the report, then get data from an external history server, click the Edit List button, and select the instance of the HDS historical alarms driver we created earlier. And finally, I'll check the electrical alarm filter I also created when configuring that driver. In the Appearance section, I'll add a table title, and then select which alarm fields to show. The fields shown here are specific to the PCVue historical alarm logs. Once that's done, I'll set my column width and we're done with the alarm table. Finally, I'm going to apply a previously created page template to our report with a header, footer, and logo. and then also use my alignment tools to neaten up the content of the report. Once that's done, let me save and then load our report. Although I scheduled the report to run automatically just after midnight, or on an event, I'm going to generate the report now from the Runtime Management Console. Once it generates, here we see the PDF report open up, showing the current values of these two temperature tags, the average humidity reading for today, the process summary table which summarizes the set of tags being logged in the PCVue historical logs, and notice that the average humidity value shows up with a red background because the average value was below 30%. We also see the line chart with the level tags logged in the Dream Report database. And finally, the alarm table on the next page, only showing the electrical alarms. The last thing I'm going to do is configure the Dream Report web portal so that we can take a look at some of the interactive tools on the web version of the report. From the Runtime Management Console, simply click Configure IIS to configure the website with all its defaults. Now that the web portal has been created, I'll open my browser to the website. And we'll select and generate the web version of the PCVue report. Since I enabled the Show Raw Data hyperlink, let's click on this value. Here we see the raw data that this calculation was based on, and if I select the chart option, we can look at a trend of this humidity tag over the specified time period. Let's look at the line chart and click on it. Because we made this chart web interactive, we can use our scroll button on our mouse to scroll in and out, pan left or right, and hover over any point to see the instantaneous value. We can also turn pens on and off using the interactive version of the line chart. Because we enable the Show Raw Data option on the web chart, we can now select the tags, view the raw data, and save it off to a CSV file if we want. So there you have the complete configuration, from configuring the drivers to connect to the various PCVue data sources, to data logging, to report creation and generation, and interacting with the report through the Dream Report web portal. We encourage you to explore the many other features of Dream Report, including the wide variety of tables, charts, and web objects, SPC charts, setpoint analysis tools, and much more for great-looking reports and data analytics. And all of this from your favorite historian, HMI, PLC platform, or any other data source. Thank you.